The Ocean Surface Topography mission aboard the Jason 2 spacecraft is poised to take its place in space to find out more about Earth and its oceans. The OSTM Jason 2 flight comes about 16 years after the first satellite was launched to measure the height of the world's seas in detail and show us how climate changes are impacting every continent. That first satellite, called Topex Poseidon, measured sea surface height down to about 1.5 inches and provided the first database of global oceanographic information for this measurement. OSTM Jason 2 will allow scientists to monitor ocean coastal regions with increased accuracy, nearly 50% closer than before. Join NASA now for a look at this mission and what it means to life on Earth.
Hi, I'm Tiffany Nell of NASA's Launch Services Program. We're about to take a closer look at the Ocean Surface Topography mission on the Jason 2 spacecraft. It's easy to think of the world's ocean as flat, blue expanses of water with waves relatively equal in shape and height. But NASA and the French Space Agency, CNES, have been working together since the 1990s to show that the Earth's largest bodies of water actually have a very dynamic topography of hills and valleys. These hills and valleys give scientists information on the heat stored in the ocean and how ocean circulation influences Earth's weather and climate. By better understanding the ocean, the minds behind OSTM Jason 2 say we can all better understand the Earth.
The oceans are an indicator of changes to come in the planet's climate. By detecting minor changes in sea surface height now, scientists may be able to better forecast the strength and intensity of hurricanes. Researchers could forecast trouble for the world's fisheries in advance, possibly in time to prevent the problems. The OSTM Jason 2 mission will take instruments into space that are similar to the ones launched on Topex Poseidon and Jason 1. Those missions have already fueled studies on new theories about Earth's climate and weather patterns. OSTM Jason 2 will help create the first multi-decadal global record for understanding the vital roles of the ocean in climate change. Data from the new mission will allow us to continue monitoring global sea level change, one of the most important consequences and indicators of global climate change.
I'm here today with Armando Piloto, the LSP mission manager for the launch of the OSTM Jason 2 spacecraft. Armando, thanks for joining us.
It's great to be here.
This mission is launching from the west coast of California. Why was that important for this flight?
Launching from California is important for this flight because of the nature of the OSTM Jason 2 orbital requirements. The spacecraft needs to be located on an orbit that is high in inclination. And the reason for that is because they want to be able to maximize their science and be able to map as much of the ocean as possible. So from a launch vehicle perspective, we can get them to this inclination more efficiently by being able to launch from the west coast.
We are a day away from launch. The OSTM Jason 2 is inside the Delta II rocket, out on Space Launch Complex 2. What work is left to be done?
Well, Tiffany, as you can imagine, a lot of work has been invested to get us to this point. We're very excited, but there are some very important activities coming up. From a spacecraft perspective, they have to go in and finalize their inspection and final closeouts. They also have to continue charging the batteries close to T0. In addition to that, the launch vehicle team is active doing their final inspection of the entire vehicle to make sure all systems are ready to go. In addition to that, once that's completed, there'll be some final connections made to the ordnance lines on the solid rocket motors, and then the mobile service tower will be removed away from the launch vehicle. Once that's completed, then we will enter the final stages of the campaign. We will go into our terminal count, and during these final hours, there's a lot that's going on. We will be fueling the first stage. We would also be doing checks with the gimbaling of the engines. There will also be several polls that are conducted during the campaign, and towards the end, the spacecraft and both the launch vehicle, once everybody's ready to go, they will go into internal power, and hopefully tomorrow morning, early in the morning, we will be having a successful launch of the OSTM Jason 2 mission.
Thanks for coming by, Armando, and good luck with the launch.
Thank you, Tiffany.
Now that we've learned more about the remaining launch activities of OSTM Jason 2, let's find out more about the science of the mission from the project scientist. Take a look.
It's a very difficult technological challenge in order to measure sea surface height with a precision of about 1 inch from 830 miles in space. This is accomplished in two ways. First, you have to know the position of the satellite very accurately. So this is accomplished with a number of instruments, including a GPS receiver, sort of like the one in your car, but a little more sophisticated, a laser reflecting array, and another system called DORIS. These essentially tell us where the satellite is. Now, the radar altimeter tells us the distance between the satellite and the surface of the ocean by basically just bouncing a radio wave off of it. So using these two pieces of information, the position of the satellite and the distance of the satellite from the ocean to itself, you can figure out the height of the ocean, and that's what the satellite tells us. Scientists use these data to help understand the ocean and its role in the climate system. The ocean is sort of like the flywheel of the climate system. It's big, it's slow-moving, and it helps move heat around the globe. So the oceans really are important to understanding climate, and measuring sea level is a really important way of measuring the oceans and their role in the climate system. The oceans absorb 84% of the heat from global warming. Now, when they absorb this heat, they expand. Just like a lot of other materials, water, when it gets warm, it stands a little taller. And this is part of the signal that the satellites measure. So satellites like OSTM, Jason, and TOPEX before it really help us measure the total amount of heat that's absorbed by the ocean. And that's a big chunk of the heat that goes into the climate system from global warming. This mission is really a stepping stone along the path of a long record of sea level rise. In order to understand climate, you really have to measure the Earth for a long period of time. And OSTM, the Ocean Surface Topography Mission, will extend our record of sea level almost to 20 years. But 20 years is not all that long in terms of global warming. I mean, this has been going on for 100 years or more. So we definitely need future missions. We definitely have to keep our eyes on the oceans because that's where a lot of the action is.
Thanks for joining us. You can log on to nasa.gov for live coverage of the launch of the OSTM Jason 2 mission. Or you can see the launch as it happens on NASA TV. For NASA's Launch Services Program, I'm Tiffany Now.